So this is the solution video for Year 10, Homework 7. If we get straight on to question 1. I did try and give you a hint here that the first question you need to go into one bracket. They both divide by 9 and they both divide by x actually, both these terms. So I need to write 9x on the outside. That leaves a y here and minus 2z there. And if you just check that works, 9x times y is 9xy and 9x times minus 2z equals minus 18xz. So that definitely works. Now some people actually took the wrong number out here. You took 3 out, leaving numbers in here that would factorise again. That's called partial factorisation. You need to take out the biggest number you can think of. On the next question, you need to think of two numbers that multiply to make 15 and add to make 8. And they are 3 and 5. That gives you that there. If you multiply that out, you'll see that that works. Same again on question C, same as question A, fully factorise. I need to think of the biggest number I can think of there that divides into these two, and it's actually 8. So those of you that took 4 out, partial factorisation, it says full factorisation there, and that is a target for the whole, well, quite a few people in this group. So let's actually take 8 outside. Are there any letters that are in both parts? Yeah, x. And that leaves 2xy there, and it leaves 3a there. And if I check that works again, 8x times 2xy is 16x squared y. Yep. And 8x times minus 3a is minus 24xa, which it says there. So it's definitely working. Now the next one needs a bit more space actually, so I need to just rub this teaching to the top out. In fact, no, I'll just squeeze it in underneath. I've probably just got enough room. I need two numbers that multiply to make 6 and add to make minus 5, and I'll tell you why if I draw a little table here. AC and B, I'm interested in those two things. Now AC in this question is 3 times 2, so it's actually 6 there, and B is minus 5. Now what I've done there is I've done A times C, so that's 6, and B is here, that's just minus 5. And you need two numbers that multiply to make 6, add to make minus 5, and if you think about it, they are minus 3 and minus 2. Minus 3 and minus 2. If you multiply them you get 6, if you add them you get minus 5. And actually what I can do is put x's on the end of there, and those are going to be my middle term. If I split this middle term up into these two parts, I can actually try and factorise this. So I need to put 3x squared at the front. That's going to go here. I need to put plus 2 at the end, and then I can continue to solve this problem. So I'll just write 3x squared there and plus 2 there. Now if I factorise in parts, I'm just going to factorise this first bit here. That is 3x brackets x minus 1. And now if I factorise just this part here, you get minus 2x minus 1. And these brackets at the end actually match. These brackets here always match, and that's going to be one of the brackets in my final answer. So one of my brackets is going to be x minus 1. The other bracket comes from these two parts, 3x and minus 2. So if I build those up and actually write my answer down, one of my brackets is x minus 1, and the other bracket is 3x minus 2. And that is a target for a lot of this group to show your method properly. I've actually shown how I've split up my terms in the middle and then factorised. That's definitely something I think a lot of you need to practice and revise. On to question 2. Number of sides. If the internal angle is 135, well first of all the external angle is going to be 180 minus that. So it's got an external angle of 45. And then if you divide 45 into 360, you can find out how many sides it's got. And 360 divided by 45 is actually 8. So there's 8 sides on that shape there. Let's move on to question 3. Being asked to find the size of angle x, well I can say that it's 30. I'll talk about y in a minute. So the first thing I'm going to just say is x is 30. So remember to actually answer the question, x is 30 degrees. But why? The reason why, this angle here equals the angle in the alternate segment. So it's actually called the alternate segment theorem, and you just write down that as your reason. So x equals 30 because of the alternate segment theorem. Question 4 requires a bit more. Now on question 4, there's lots of good answers to this question. A lot of you spotted that this is the angle in the middle, and this is the angle at the circumference, and so this one here must be half the size of this one here. So actually a lot of students have realised that this is 40 here. And you'd have to write down the angle at the centre is double the angle at the circumference. That would be part of your fully worded reason. Now if you didn't get the 40 bit there, you're not going to get the rest of it right, unfortunately, which is a shame, because the rest of it's fairly straightforward. If we look here, we've got a straight line. So the angles on this line here add up to 180. So if this bit's 40, this bit must be 140. So I could write my answer down. X must be 140. Listen to the second part of the reason. Angles on a straight line add up to 180 degrees. So if I was going to write the whole reason down all in one go, I could write the angle at the centre is double the angle at the circumference, and angles on a straight line add up to 180 degrees. That's the end of that question. Solving equations. Let's take 9 off both sides. So 3x equals 6. Divide both sides by 3. X equals 2. This question was really well answered by the group actually. Question B. Take 18x off both sides to give me 2x plus 4 equals 20. Now at this point there's 2 or 3 people that take 4 away from both sides and actually made a mistake. Take 4 away from both sides, you get 16 there. Some of you wrote 18, which is a shame. Divide both sides by 2. You get 8. On question 3, expand your brackets first. 3x plus 21 equals 5. Take 21 from both sides to give you 3x equals minus 16. Divide both sides by 3. You'll end up with minus 16 over 3, and you can leave the answer like that. Part D caught some of you out. I need to, first of all, just dump my minus signs. They're not in the questions. You can just multiply both sides of the equation by minus 1 and the signs disappear. So I'll just end up with 2x equals 0.5. Now, to solve this problem, you actually need to halve both sides of that equation, and half of a half is a quarter. Question E, the worst one on this page for a lot of you. There's a 3 here. I need to multiply everything by 3 to make this 3 go away, and that's convenient because that's got a 3 as well, so that 3 will also go away. Times by 3, times by 3, times by 3. Let's multiply everything by 3 and see what happens. X minus 2 equals 12. That's what happens when you multiply everything by 3, and then add 2 to both sides to give you that. And that method is a lot simpler than some of you have done. So even if you've got that question right, you might want to look at my method and how simple that is compared to yours. Let's move on to question 6. And question 6, again, this is a very well answered question for the majority of the group. Let's say 5 or 6 people have got it wrong, but that means 24, 25 people have got it right. You need to work out the area of the trapezium, take away the area of the triangle. Let's do the area of the triangle first. The area of that triangle, half base times height, is half of 18, so actually the triangle is 9 square units. So I'm going to take 9 away from whatever the trapezium area is. Now the area of the trapezium, listen to the rule in words. Add the parallel sides, then half it, and then multiply by the distance between them. So I'm going to add the parallel sides, there's one of them, there's the other one. So once I've added them, half it, then multiply by the distance between. So let's write that down. Area of the trapezium. Add the parallel sides, then half it, then multiply by the distance between. Now 20 add 14 is 34. Half of that is 17. Times 10, 170. Now that's the area of the trapezium. Taking from it the area of that triangle that we worked out earlier on. So we've actually got 170. That looks more like a 7 now. 170 take away 9, which is 161 square units. And some students did actually do this calculation here wrong. There's a few people in the room that have done 170 take away 9 and written 163, and that's a strange mistake for several people to all be making. So if you are working with someone else on this homework, you need to be careful that you do hand in your own work and you're not copying off other people. So that's the end of that question. Let's move on to the next one. Final question. I'm gathering root 6's together on this first question. So let's have a look at this. I've got 3 root 6's plus 2 root 6's, that's 5 root 6. But I'm taking away 1 root 6, so I'm left with 4 root 6. So that one's quite easy. Root 45, whenever you're splitting this up into the form a root b, you always write a square factor and a non-square factor like that. The biggest square factor you can think of, and of course root 9 is 3. So end up with that, 3 root 5. Same question actually on the next one. If you look, this is root 45, but this is 2 of them. So it must be 2 of these. And actually 2 times 3 is 6. So it must be 6 of these. So the answer is 6 root 5, because that question is actually connected to the question above. There isn't a great deal of room for me to write this next one, but I'll try and squeeze it in. It's to do with root 2, this question. This first bit, root 8, is actually 2 root 2. That means the next bit along must be 6 root 2 for the same reasons as this answer above. Now, root 72 is not as obvious. Let me just think about this. Root 72, thinking about how we split up root 45, I need a square factor and a non-square factor. And so actually that's going to be 9 times 8 is 72. So it actually turns into, well, in fact, no, it can do it even better than that. Root 36 times root 2. That's the best way of doing that. So root 36 times root 2. And of course, root 36 is 6. So this last bit here turns into minus 6 root 2. So I end up with 2 root 2 plus 6 root 2 minus 6 root 2. So these bits cancel out. You end up with the answer 2 root 2. Now you're supposed to be fixing your homework, changing, correcting it with purple pen and making little modifications to questions that have gone wrong and so on. Please can you make sure you do that, and then I'll be checking that next week when I collect homework 8 from you. As usual, if you're stuck with this video, you've watched it a couple of times, still don't know what I'm doing to solve these problems, you can come and see me for help. It's particularly useful if you do that at break time, because I'm available then. That's it. Thank you.